Okay, so the two images that we're looking at are images that explain both how hydroxyurea and L-glutamine work in the bloodstream to help prevent oxidative stress and ultimately vascular occlusive events, crises, acute chest, and any of the other wonderful things that come along with the act of sickling and having sickle cell. So, the top image, which is the whole image that is above this circle right here by my head, that top image is only dealing with hydroxyurea. Okay. So if we can remember, hydroxyurea is a low dose chemo that helps to promote the body making fetal hemoglobin. Fetal hemoglobin does not sickle, only adult hemoglobin sickles. And this is why children with sickle cell under the age of 6 experience less problems with sickle cell than they do over the age of 6, because it's between the ages of 4 and 6 that the body really ramps up its production of adult hemoglobin and replaces something like 95% of the fetal hemoglobin with the adult hemoglobin, which then ultimately raises the probability of the child having all of the complications that come along with sickle cell. Okay, so if we look at the very top um, image, what you see is the sickling process, just period. So you have your round shaped blood cells, um, and they're dropping their oxygen molecules, you know, as they're supposed to do. And then you have your blood, sickled shaped blood cells. And next to them are the word NO, meaning no oxygen. Um, and you see how now they're shaped different, they're moving different within the vein, and ultimately you see the heme, these little sort of clear globs on the side of the vein wall. Those are the blockages everyone likes to refer to as if they're no big deal. But you see those formed on the side of the vein wall. When you get to this middle image, the tan one, what you see is the hydroxyurea at work. And there are a number of little, I'm not quite sure how to describe them. Honestly, they look like the nerds candy. Let's just call them nerds. So you see these little pink and red nerds over here. Some of them look frosted. This is the hydroxyurea, and it has entered the bloodstream and is now producing fetal hemoglobin. And you'll see red blood cells with a line directly connected to our little nerds here. And those red blood cells have F's on them, and that F obviously stands for fetal hemoglobin. And ultimately, as the image tracks downward into this last one, what we see is the fetal hemoglobin entering into the bloodstream alongside the adult hemoglobin. So there you have your fetal hemoglobin. Okay, Next to it is your adult hemoglobin. And as it goes into, I hate this, um, into the next image, you see a significant drop in sickled cells from the top image. So up in this top image, you see all the sickled cells and the blockages that they've caused. But then, now that we've added hydroxyurea and it's now producing fetal hemoglobin, we now see a decrease in sickled cells and blockages. There you go. So, bottom line. And ultimately, as I said in the previous video, hydroxyurea is a preventative medication. So, it's an investment in your body. It's protecting your organs in the end. And it's preventing in organ damage, organ failure, specifically within the spleen and your kidneys and renal system. And just to give you an idea of how significant that is, most sickle cell patients don't have a spleen by the age of 10, going into like their mid-teens. Either our spleen has shriveled up or it has become engorged and it is causing all kinds of problems. And generally, it's on the verge of being taken out. And then the next organ to go would be our gallbladder, which we lose somewhere in our mid 20s. So by the time we're 30, we're already down 2 organs. Just an idea of what that looks like. So hydroxyurea ultimately is helping to protect your organs from the chronic damage that sickle cell causes. And now in our bottom image in this circle, it's showing glutamine. And basically, glutamine allows the oxygen molecule to cross the water membrane barrier of organs and tissues and whatnot. We don't make it. And because we don't make it, we have a lot of oxidative stress. Because one, we're dealing with a very sophisticated, very, very determined form of hemolysis, which is when the body breaks down its own red blood cells. For us, it's doing that in the form of sickling. And then on top of it, we don't make the thing that allows us to have multiple ways of delivering oxygen throughout our body. That's the L-glutamine. So this picture is just showing um, what happens when L-glutamine is introduced into the body. And ultimately, what it does is it's breaking up. Um, it's breaking up the barrier, parts of the barrier in the membranes that allows the oxygen to pass through, and also hydration. Okay, I'm not a nurse. I'm only a patient. If you are a nurse and you can explain that better, or you're a doctor, explain it smoother, please go for it. But guys, this is the visual that no one ever shows us. Um, I hope that's helpful. I hope this makes you look into both hydroxyurea and Endari, which is L-glutamine. And I hope that you remember that sickle cell is indeed your superpower. Thank you.